Hi everyone, in this lecture we will see how to find an element occurrence in a sorted array. Okay, so we can use the find function, but it is slightly inefficient. If the array is a sorted one, we can use binary search that works in order of log n time. So instead of making our own binary search function, we will use a function that is available with the C++STL. So you can say bool present equals to binary underscore search. So this function returns true or false depending upon element is present or not. So you want to search in this particular array starting from 0 till the n-1 index, and here you will give the key, what is the element you want to search, and you can check if this is present. You can say cout present, else you can say it's absent. This is as simple as that. Okay, so we are making this function call that is provided by the algorithm header file. Okay, so let's give in some input. So if we give, let's say, element 100, we will get if this element is present or not. So 100 is present, and if I give, let's say, 140, then this element is absent in this array. Okay, so this is how easy it is to use the binary search function. And two more things I want to discuss in this video. One is, suppose you want to get the index of the element, okay, where this is present. So for that, the algorithm header file provides us with two functions. One function is called lower bound, where you give the start and the key, and another function is called upper bound, where you also give start and the key. So let us try to use the lower bound function. So these functions actually return the address where the element is stored, and we are calling that variable as iterator. Okay, you can make it of the type int star, but I'm just making it auto because it's an address of a bucket inside the array. We can just make it like this as well. Okay, so let me call auto it, and we are going to call lower bound function on this array. Okay, so this is array, and let's try to search for the lower bound of the number 40. Okay, so let's say this number is 40. Okay, so what does lower bound will return? A lower bound function will return me the address of the first bucket that is greater than or equal to key. Okay, so this is my key. So it will give me the first element that compares greater than or equal to key. So in our case, we do have the number 40 in the array, and the index of the first occurrence of 40 is 2. So we should get the address of the bucket 2. And if you want to get the index, you can simply say it minus arr. That is going to give you the second index. So let us see if we get the index 2. Okay, so yeah, we are getting this thing. So we are getting the output as 2. Okay, let me say this is lower bound of 40. And what about upper bound? If you want to see what is the first number that is greater than 2, lower bound of 40 is 2. Okay, so let us also discuss how to use the upper bound method. So the function call is very similar. So instead of calling lower bound, we will call upper bound. So remember, this lower bound is going to give you the first element that is greater than equal to key, and upper bound is going to give you the first element that is strictly greater than key. Okay, so let us have a look at the occurrence of first element that is greater than key. So this element is going to be 50. So if you calculate this index, this is going to be 0, 1, 2, 3, 4 and 5. So upper bound is going to give you 5, lower bound is going to give you index 2, and if you subtract upper bound minus lower bound, you're going to get this number of elements, that is 5 minus 2, that is 3. Okay, So suppose the question is you want to find frequency of an element in a sorted array. Okay, if you want to do this, so clearly this can be done using 5 minus 2, that is 3. The number of elements will be equal to 3 in this particular array. So let's do another thing. Okay, so see out upper bound is this, see out occurrences of 40 are, or you can say occurrence frequency of 40 is upper bound minus lower bound. So maybe upper bound, let's call it lower bound, and here we say okay, lower bound minus array, upper bound minus array, and we can say this is nothing but upper bound minus lower bound. That's it. And you can see we can just find occurrence of this any number in logarithmic time, because both upper bound and the lower bound functions, they work in log n time. So let's see the output. So occurrence frequency of 40 is equal to 3. And you can also verify if an element is not present. Okay, so you can say if a lower bound equals to n in this case, or lower bound minus this thing, array index. Okay, if this is equal to n, you can say element is not present. See out element is not present. So if I make this element as 41, so this is not present, and you will see this thing. Okay, okay, we if you give 41, then you will get the next element, that is uh, 50. Okay, so lower bound in this case will give us 50, lower bound of 40 is 5, because it gives us the first element that is greater than equal to key. So if you want to check if the element is present or not, you first make a call to binary search function, that you should do. Okay, so you will get this. So lower bound of what is 5, so you're getting 0 1 2 3 4 and 5. Okay, so this is what you will get. And occurrence frequency of what is 50, because in such a case both lower bound and upper bound will be same. Okay, so you actually do not need to do this thing. Either you can check the frequency or you can check, but yeah. Okay, so you should ideally use binary search to check if an element is present or not, and if it is present, then you can use the lower bound method to check where it is present for the first time. Okay, so that's all for this video, and we will talk about more concepts in the next video.